A material which conducts electricity without any resistance is known as superconductor, and the phenomenon is known as superconductivity. The first superconductor was discovered by the Kamerlingh-Onnes in 1911, which was a Dutch physicist. During his experiment, he observed that whenever we cool down mercury below a certain temperature, then it starts superconducting behavior and conduct electricity without any resistance. The critical temperature for mercury is 4 Kelvin. Then after that, different scientists made their contribution, and niobium was discovered as a superconductor. And then after that, the yttrium barium copper oxide, the copper thallium based superconductor, shows superconductivity up to 138 Kelvin and even shows superconducting behavior up to 168 Kelvin, but that was at a high external pressure. In 2018, material like titanium and hydrogen shows superconducting behavior up to minus 13 degrees Celsius. And now finally the wait is over, because scientists Ranga Dayas and their colleagues discovered superconductivity at room temperature. Ranga Dayas and their colleagues observed that whenever we place material like carbonatium, sulfur hydride, which is also known as the carbon, sulfur and hydrogen, whenever we place these material between the tips of the diamond and targeting it with the laser light, then certain type of chemical reaction occurs, and by increasing the external pressure, it start superconducting behavior or shows superconductivity below a particular critical temperature. But when we increase the external pressure, then the superconducting transition temperature increasing, and by increasing the external pressure up to 2.6 million times of the earth atmospheric pressure, the material shows superconductivity up to 15 degrees centigrade, which is a tremendous landmark because it is almost a room temperature. But still there are so many other questions here, which is basically mentioned by Ranga Dayas and their colleagues, that still about the structure of this material is not known. And similarly, this material is basically, although it is a room temperature superconductor, but still it is under high pressure. This achievement is under high external pressure, which is 2.6 million times. It means that it is not a normal atmospheric pressure superconducting material. And if scientists achieve normal atmospheric pressure superconducting material and normal room temperature superconducting material, then it will be a tremendous landmark and it will be a tremendous achievement, because we know that there are so many applications of superconducting material, like it is maybe used in the electronic devices. We know that there are so many energy losses in electronic devices. We know that it is used in the superconducting quantum interference device in squid. We know that it is used in squids, the superconducting material. Similarly, the superconducting material uses in the MRI machines. MRI machine is so much expensive because very cool temperature required for that. Superconducting coil used in the MRI and high magnetic field used in the MRI. Similarly, we know that in tokamak machine we need a very high magnetic field for the formation of the fusion plasma, and for that we know that superconducting material are used. So that's why superconducting material are of great importance. Similarly, for the another application is the magnetic levitating train. We need for the levitation a high magnetic field and hence a good superconducting material. Similarly, we know that the superconducting material is used in the Large Hadron Collider, and similarly so many other applications. So if the superconducting material at room temperature and normal atmospheric pressure is achieved, then it will be a great achievement, and billions of dollars will be saved by each country, because so much energy is preserved in this regard. So I think it is a good achievement, a best achievement. It opens a gateway for further research in this field. So still we will wait for that in order to see the room temperature as well as the normal atmospheric pressure superconductor. Thanks for your time for watching this video. Thanks.